what will happen is the ring will take somewhere position like this, and the bob will be somewhere here. Okay, the basic first student has to develop what actually goes on. Okay, then what we can do afterwards. When you don't know what is going on, then how you write equation? This is what the physics. What if many will answer how to solve problem? How to solve problem? What actually happens? What actually goes on? Okay, again after this we'll get this position, and from this position again it will be like this. So like this it will be in oscillation, it will be there. So how the motion of the ring will be like this, will be oscillating along the rod. The ring will move, will describe to and fro motion along the rod, whereas the bob, what happen, will oscillate about a point where the point is describing to and fro motion. That's what our question it is. Getting the idea now? Okay, let's get into the calculation part. In the simplest thing, shall I say that the pendulum is oscillating about a point which is also executing SHM, to and fro motion, or is executing SHM about a point which is accelerating. The point of suspension is not fixed, it is also vibrating. So this is the theta. Okay, the moment I release, what are the forces? The tension. So let me call F here, because capital T is what we'll be using for time period, no? And the weight of the bob. So what is the force? It is acting in this direction. So there'll be an acceleration of this will be there. Let me call that as A1 or anything it can be. What is F? F is the tension in the string. Now it is going to execute SHM about a point which is accelerating. So shall we put one pseudo force? Try to see this. This is pseudo force. Okay, now about point O, we'll write the torque equation. So T sine theta. So first F sine theta should be equal to M1A1. F sine theta should be equal to M1A1. If you want, you write A naught. Okay, let it be A1 only. So there's the equation 1 you can take. So this is for the ring. Now, similarly, let's come for along y-axis F cos theta. I'll release it, no? F cos theta minus M2G equal to 0. This will be theta. Then let's go for torque about point 2. All will set torque M2G. This will be L sine theta. Length of the string is L. Torque due to this M2A1 L cos theta. This should be equal to how much? Torque moment of inertia of this. This should be equal to M2 L square alpha. In place of what all we can write it. A1 shall I write it as F sine theta by M1. Call equation 1, 2, and 3. So what we did, put 1 in 3. Again, what is F? F is unknown thing. So M2G by cos theta. So what is F? F will be, so now 2 in 3. M2, this will be M2G cos theta sin theta M1 L cos theta. One M2 gets eliminated. One L also gets eliminated. So L alpha is equal to G sine theta plus M2 by M1. Cos theta gets eliminated. G sine theta. So therefore alpha is equal to G sine theta you take outside by L, let it be here, M1 plus M2 by M1. So this negative sign, I'll bring it here. Alpha equal to minus GL. Comparing with standard equation of SHM, so I'll get time period 2 pi is equal to L by G. Okay, this is a time period of oscillations of this pendulum. It also depends mass of the ring also. You can see this. Okay, you can do one thing. This is a, you find little bit very difficult. Let's try to understand this in this way here. If M1 is very large, if it is a wall, if you suspend this to a some wall or ceiling, what is the mass of that ceiling? Will be so large than Bob, no? If M1 becomes infinity, then 1 by infinity will be 0, then it got 2 pi root of L by G. The same thing is what the first pendulum is what we started. Okay. If it's directly instead of ring, if it is directly connected to ceiling, so I'll show it nearby it. This is M2. Mass of ceiling is infinity. In that case, the expression will become, if the mass of Bob negligible compared to mass of the point of suspension, then it will be 2 pi root of L by G only. I'll scroll down. See, again, we are not doing anything very big. Just we are calculating the time period, we are calculating the torque about a point which is accelerating. Again, the same method. Torque due to pseudo force, torque due to weight, torque due to F. Why it is 0? Because it will intersect axis of rotation. Therefore, the torque due to tension will be 0. What is F? F is a tension here.